Alright, so I shared my screen. Say yes in the chat if you can see the screen. If you not, say no. Okay. So today we're going to be starting a new unit. Okay. This unit is going to be about functions again. Alright. We briefly touched on functions in I think unit 4, but today we are going to go more in depth with functions and function transformations and that kind of stuff, a little bit more advanced. Okay, but first let's just um, go over the schedule. First, we're going to learn about the 4 parent functions that we're going to be working with this unit. Then we're going to go over the 4 main function transformations. Okay, the main ones, and then we're going to do some practice problems. Okay, so first let's go over homework from last class. So just quadratic equations. I'm going to solve it by, I think, all 3 methods if we can. So let's see here. Let's just move this negative 8r to the other side. Minus, actually it's going to be plus now. Okay. All right, I'm going to give you a couple moments to solve this problem. All right, put your answers in the chat, and then I'm going to walk you through this one. Okay. All right. Let's see here. We have -13 and 5. Very good. And yes, I have pulled up the Desmos graphing calculator because we'll be using that later in the class to show the function transformations. Okay, so let's go over this problem real quick. I think you can factor this, right? Can we factor this? Pretty sure we can. Um, let's just go, it's 13 and 5, right? So it should be r plus 15 and r, actually not 15, r plus 13 and r minus 5. Okay, so that's equal to 0. And then r is going to be equal to 5 and -13, right? So let's try to do it some other way. All right, let's say that we're back here. Okay, we've moved everything to the other side. What are some other methods? All right, we can use completing the square. So let's try that. All right, so it's gonna be plus 16, right? Because we want to make r plus 4 squared, right? But if we're adding 16, all right, we have to make that equal to this, right? So we're going to also have to subtract 16, all right? So basically, in total, we're subtracting 81. Okay, let me get out my calculator to see if that's correct. Never mind, I lost my calculator. Let's just hope it's correct. Yeah, it's correct. That's pretty sure. All right, so then let's just move this 81 to the other side. Okay, should be r plus 4 squared is equal to 81. You square root it, it should be r plus 4 is equal to plus or minus 9. And we do get -4 plus or minus 9, which is equal to 5 and -13. Okay, so those are the main two methods. All right, you could use quadratic formula, would not recommend it. I mean, it's pretty clean this time, right? Not too many, dirty numbers or just too many fractions. But always try to use factoring, right? Factoring, it's so easy. It's just like 2 steps, right? So always try to use factoring if possible. All right, if it's not applicable, then you can try completing the square. It's always nice to do that. Or you could directly use the quadratic formula, but don't use the quadratic formula until you absolutely have to, because most of the time it's pretty ugly when you have to use it. All right, so let's do this next one. Okay, so put your answers in the chat. All right, so let's go over this one real quick. For this one, I'm going to call up a volunteer. All right. So who wants to volunteer? Help us how to solve this. Okay, how are we gonna? Let's see. Okay, William. All right. How did you do it, William? Wait. First, let me move everything to the other side first. Okay, so plus 11a plus 6. Okay. All right, now do it.
I used the quadratic formula for this. So basically it is the B is A is 3, B is 11, and C is 6.
Very good. So
So it is
Mhm.
so it's negative 11 plus minus the square root of 121 minus 72 over 6.
And that is going to be equal to.
And that is negative 11 plus minus square root of 49 over 6. Then it is negative 11 plus minus 7 over 6. And that will be equal, so that which means that A is equal to A is equal to negative 4
Are you sure?
6. I mean negative 4 6 or negative 3.
Very good. Very good. Okay. Um, very good job. Okay. I don't think we made any mistakes. Yep. I think that's correct. Okay. So that is one way to do it. First of all, before we even do anything, let me see if we can factor this. All right. William, did you try factoring this?
I just started with the quadratic formula because I didn't really bother thinking too much about like factoring, and that if it didn't work, I would like have to do the quadratic formula anyways.
Okay. Yeah, I understand that because I would probably start with the quadratic formula too, because this doesn't look very factorable, but it actually is. All right, so let's look at this, see if it's factorable. Okay, so we can actually see here that it's going to be look at this. Okay, it's going to be a plus 3 and then 3a plus 2. Okay, so always at least try, right? So it's going to be equal to negative 3 and negative 2 over 3. All right, so that's factoring. Now, William, could you help us complete the square? Actually, no, let's not do that. Um, to complete the square, we actually have to divide everything by 3, so that looks way too complicated, right? With all the fractions and stuff, we could make a lot of computational errors. So when you have something like that, just don't bother trying. All right, it's not going to be worth it, and if that's your first resort, you're probably going to make mistakes anyways. All right, so now let's try this one. All right, this probably doesn't seem factorable since 17 is prime, right? It's probably not factorable. So I guess you either complete the square or you use the quadratic formula. All right, so let's see what you guys got. I'll give you actually I'm just gonna call up volunteer right now. Okay, so let's see. Let's see if we got someone different this time. How about Ethan? Would you like to volunteer?
Okay.
All right. So let's just start with the quadratic formula. What is the A term in this case?
1,
And B?
negative 12, negative 17,
Okay, so therefore X is going to be equal to what is it going to be equal to? just start with just plugging the numbers into the quadratic formula, right? So what is negative b?
12.
All right, and then it's plus minus the square root of what is b squared?
144.
Good. So, and then what is AC? A times C.
Negative 17.
All right, then what is
Wait, isn't it 4AC?
Yes, it is. So now we're gonna multiply 4. So what is 4 times 17?
Do you mean 4 times negative 17?
We're going to subtract negative 4AC, right? So technically we're
Oh,
adding,
okay.
right? So what is that?
68.
Good. All right, let's just add that up real quick to 144. That's an ugly number. Okay. It's 212, which I don't think we can simplify, or it's not a perfect square. So what is 2a?
Just 2.
Good. All right, so let's try simplifying this. So let's take this to the other side. What are some factors of 212?
2.
All right, after we divide by 2, it's going to be 106. Can we still divide by 2?
Yeah.
All right, so that's going to be 53. And you see we have 4 over here, so it is divisible by 4. So let's take that 4 out. That's going to be 2 times the square root of 53. All right, so therefore our answer is going to be 6 plus minus the square root of 53. All right, very good. We got the answer. All right, Ethan, I would like you to help me completing the square now. Okay, so let's try completing the square this time. See if we get the same answer. So the square we're trying to complete here is going to be x squared minus 12x plus 36. Right, that's the square. That's going to be equal to x minus 6 squared. All right, so to get to that, let's just move the 17 to the other side. All right, Ethan, what do we need to add to both sides in order to get this?
36.
Very good. So you get 36, right? All right, so don't forget to also add 36 to 17, which is going to be 53. Okay, so after you do that, you can see that it's going to be x minus 6 squared is equal to 53. All right, then what you need to do is you need to take the square root of both sides. X minus 6 is equal to this plus minus square root of 53. X is equal to 6 plus minus the square root of 53, and we get the same answer. All right. Okay, very good. All right, very good. All right, so that was the last homework problem. So let's just start with our new material. Okay, so let's just recall back to when we learned about functions. Okay, so what are some things about functions that everybody remembers? Okay, so first I'm going to ask you in the chat. All right, so everybody put something in the chat. All right, what is the domain of a function? All right, so recall, what is the domain of a function? All right, so you can put in the chat your answer. Very good, Zero. All the x values, okay? All the x values. And yep, it's all the x values, okay? Now, what about y? What is all the y values called? All right. Besides domain, what is all the? Very good. It's going to be range, all right? The range is all the y values, okay? So basically, remember that a function is a correspondence from the domain to the range, right? So it's like input and output. You input is x, all right, and the output is y, right? And you can't have an x cannot correspond to multiple y's. However, let's just look at this. So for example, a circle, that is not a function, right? Because let's say 1 here as an x value corresponds to 2 y's, all right? 2 y's over here, which is not possible. All right. But you can see that it's possible to have a line like this and still be a function because multiple y values can correspond to one x value, right? Well, no. Multiple x values can correspond to one y value. So we can just have a constant y value here, and that's still a function. And we call this the vertical line test. If you can run a vertical line through every part of the function and not having the vertical line cross the function twice, then it is a function. Okay. So now let's learn about the 4 parent functions and just keep domain and range in mind. All right, so let's just try to graph these with a table of values. All right, so I'm gonna call up some volunteers. Okay. So how about Kaylee? Could you help me with this one?
Sure.
All right, so let's just x and y. All right, so if x is going to be equal to -3, what is going to be y? All right, y is basically absolute value of x, right? So what is y?
Is it 3?
Good. So -2,
2,
-1,
1,
0,
0,
1,
1,
2,
2,
3.
3.
All right, so now let's plot these points. All right, let's just make this graph real small here. Okay, since we don't have that much space. So -3, 1, 2, 3, and 5, 1, 2, 3. Okay, here, 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 on same on the other side. As you can see, the graph of absolute value of x is going to be something like this, right? It's like a V, right? Because since we have the absolute value, right? So it's going to be like a V here. All right. So that's the parent function. Y is equal to absolute value of x. Okay. So now let's look at the domain of it. All right. So Kaylee, what is the domain of this
Um,
in interval notation?
is it infinity to infinity?
Very good. It's -infinity to infinity because you can see we have arrows that are going on forever. All right. Because if you put in any x, no matter what x it is, as long as it's a real number, y is always real, right? Because when you look at domain, we look at restrictions. There are no restrictions on x. There are no restrictions. But if you look at y, all right, what are some restrictions on absolute value? It has to be greater than or equal to 0, right? So therefore, our range is going to be equal to greater than or equal to 0, 0 to infinity, all right? And you'll see here in this graph. Okay, so now let's just quickly just complete the other ones. All right, Kaylee, so let's just see if x is -1, what is y?
Uh, is it like impossible?
Yeah, it's undefined, right? If it's undefined, we have a little 0 with a slash here. All right, that's how we tell. Okay, so what about -2? If you have -2, can we have a y?
No.
It's also impossible, right?
Yeah.
So what can we conclude is that this domain excludes
Negative numbers.
yeah, very good. It excludes negative values. All right, so now let's look at 0. We get 0. We have 1, we get 1, and 4, we get 2. All right, so now let's graph this. All right, so since we can't have negative values, we actually just start from 0. At 1, all right, we get here, and then at 4, we get 2 here. So it's going to somehow look like this, right? Okay, so Kaylee, what is the domain of this?
Is it bracket 0 and infinity?
Very good. And the range is going to be?
Non-negative.
So
So,
also the same, right? Very good. So now let's look at these other ones. Okay, so if x is going to be equal to -3, what is y?
y is going to be 9.
What about -2?
-2 is going to be 4.
-1?
1,
0?
0,
1?
1,
2?
4,
3?
9.
Good. Okay, so you can see here from our values, well, you can instantly see from the absolute value of x, what is this symmetrical to, right? It's symmetrical with respect to the y-axis, right? And about this x squared, all right, is equal to x squared. That's called a parabola, all right, because it looks like a U, all right. Parabolas are basically just U's or upside down U's, all right. It looks like this, right? That's what a parabola looks like, all right, and it's symmetrical with respect to the y-axis, all right. And the domain, what is it going to be?
Is it going to be negative infinity to infinity?
Very good. And the range is going to be?
Negative infinity to, oh no, it's 0 to infinity.
Good. Okay, so now let's look at our final one, which is x cubed. All right, if x is going to be equal to -3, what is y?
It's going to be 27.
-27.
Oh yeah.
What about -2?
-8.
What about -1?
-1. Yeah. -1.
Good. And 0?
0.
1?
1.
2?
8.
3?
27.
Good. So the graph is going to be looking something like this, right? This is going to be x cubed. All right, so everybody take notes on this. Remember what this looks like. Okay, so and the domain on says -infinity to infinity. Range is going to be also -infinity to infinity because there are no restrictions on the domain. Okay. All right. So those are our 4 parent functions. All right. So everybody remember them. Of course, we have a line. We could also have a line, but we already learned about those. These are our new parent functions. Okay. Okay. So now let's talk about function transformations. So this is our first transformation. All right. We're going to so throughout this, I'm going to use this graph. All right, let's make it bigger. Throughout this demonstration, I'm going to use this graph. Okay, this is, let's see here. Let's make this 2. I'm just going to use this graph as a demonstration graph. Okay, it's very simple, right? So let's look. We see that f of 0 is going to be equal to 0, f of 1 is going to be equal to 2, f of 2 is equal to 0, f of 3 is equal to -2, f of 4 is equal to 0. All right. So that's basically our demonstration graph. So what if we created a new function that was f of x plus a, where a is like a real number, right? So let's just say f of x plus 1. Okay. So let's make a chart. So f of x and f of x plus 1. And you can see here, let's say 0, 1, 2, and 3, and 4. Okay, for our regular f of x graph, we get 0, 2, 0, -2, 0. Okay, and then plus 1, we get 1, 3, 0, -1, 0. Oh, no. 1 and 1. Okay, so basically what we did when we added 1 is we just shifted it up, right? Okay, so this is our normal one. Our normal one was, let me draw, like this. We shifted it up, okay? Up by 1. All right, so what is this? This is a vertical shift. All right, let's try to model that. So I'm just going to use this because it kind of looks like the sine. This sine graph kind of looks like our demonstration graph, right? Kind of squiggly, right? It's trigonometry, so we won't learn it, but it's good demonstration. Okay, so let's say we add a to this. Okay, we add a. All right, and you can see if we just let this play, right? The a, what it does is, okay, what it does is it shifts the graph vertically, right? You see? All right, it shifts the graph vertically. Okay, you just add a to the y value. That's basically what we're doing, right? Okay, did everybody see that demonstration? All right, say yes in the chat if you can see that demonstration. Okay, yes. Okay. All right, yes. Very good. Very good. All right, and Zebo, very good. If function is symmetrical with respect to the y-axis, it's going to be called an even function. We're actually going to learn more about those in later classes. Okay. All right, so now let's look at g of x is equal to f of x minus a. All right, so this is important because it directly affects the x, so it's going to be effect on the domain. All right, that means it's going to be shifted horizontally, right? It's going to be shifted horizontally. Okay, so let's see here. All right, so let's make our chart. Let's say -1. Okay, so now let's 0, 2, 0. No, actually 0, 1, 2, 3, and 4. Okay, so then it's going to be 0, 2, 0, -2, and 0. This is going to be f of -1. Okay. And this is going to be f of 1, f of, actually, f of 0. That's going to be f of 0. And actually, we can't model it like this. All right, first, let's see the domain, okay? Actually, let's try to see the domain, okay? So what is the current domain? It's going to be 0 to 4, right? So 0 to 4. And to find the new domain, what we're going to have to do is we're going to have to do this. Okay, so basically, right? Let's say we were going to do f of x minus 1. All right, we're going to put x minus 1 inside this inequality thing. Okay, so 0 to 4, right? And you see x minus 1, you might think that it shifts left and actually shifts right. Since if you solve for x, it's going to be 1, x, and 5. All right, so basically what we did here was we shifted it right. So x minus a is, assuming that a is positive, then it's going to be shifting to the right. However, when x is adding a, or assuming a is positive, it's going to be shifting left, right? So don't get fooled, because you might think that minus a means shifting to the left. Not really, okay? It's going to be shifting to the right. You got to look at the domain. This is why it's tricky. Now it's this is horizontal. Okay, let's see. All right, so let's add parentheses minus a. Okay, so you can see here it shifts horizontally, right? When a is positive, it shifts to the right. When a is negative, it shifts to the left, right? Okay, so now let's go to stretch slash compression 1. All right, this is when we're multiplying something to the y value. Okay, we're running out of time, so I'm just going to show you what happens, right? This is going to be a vertical stretch, all right? So when we multiply c to it, basically we're directly multiplying the y value, right? So what we get is something like this. We get something like this because we stretch it, right? We stretch it, or we could get something, all right? This is a regular one, or we could get something like this. We compressed it, right? So if c is greater than 1, okay, we're gonna stretch. If c is between 0 and 1, we're gonna compress, right? Because we're multiplying fraction to it. Then we compress the y value. If it's greater than 1, we stretch it. Now, obviously, if it's 0, well, there is no y value anymore, right? There's no function because we multiply 0 to everything. 0 just ruins everything. And of course, if it's just equal to 1, nothing happened. You're multiplying 1 to something. It's still going to equal that same something. So let's model this on Desmos. As you can see here, okay, if you multiply c, okay, you're going to get something like this, right? It stretches vertically. It stretches vertically, right? Okay. And very interesting observation here. If C is negative, they're going to reflect with respect to the x-axis, respect to x-axis. As you can see here, let's go back to Desmos. All right, as you can see here, once it changes from positive to negative, you can see, let's stop it here. All right, it switches, it reflects, right? It reflects. Okay. So then we get something, like this. Okay. Now let's go over our final stretch / compression. Again, this is interesting. Let's say f of 2x. Let's put this, let's find the domain of this, right? 0 to 4. Well, you see, 2x, contrary to what you might think, does not actually stretch it, it compresses it horizontally. All right, compresses it horizontally. From this, we can see that it's gonna look like this is the regular one. All right, this is regular one. What is this? It's gonna look like this, really skinny, right? And today we might have to go over time. All right, so if you really don't have time, you can just leave. But I'd like most of you to stay to look at the practice problems. I'm sorry that we had to go over time a little bit, maybe 5 minutes. Okay. So it compresses horizontally, right? So this is horizontal compression or horizontal stretch / compression. All right. So from this, we can see a couple of rules here. If C is greater than 1, we're going to compress by the factor of C. If C is in between 0 and 1, we're going to stretch by a factor of C, right? Because if you get like 1/2 of x, you can see that the domain is stretched by a factor of 2, right? Like that. Let's see on Desmos, okay? You can see it's like a spring, right? It's like a spring. You stretch it horizontally. Okay. So also note something. Okay. Let's see. A sine graph knot might be good for this. So how about let's try it with this. Try with x cubed. Right? As you can see here, we stretch and compress horizontally. And I chose this x cubed, right? Is because it's not symmetrical with respect to the y-axis. And we can see that when C is negative, we actually reflect across the y-axis. All right, so there gives another point. All right, if C is negative, reflect across the y-axis. Okay, so now let's do some practice problems. And before we do that, let me say first order of operations kind of with functions. First, you're gonna do horizontal shifts. This is number one. You're gonna do that first. Next, you're going to do any horizontal stretches. Okay, just direct effects on the domain. You're gonna do first. Then you're going to do some vertical stretches. All right. It's number three. Okay, and finally, we're going to have the vertical shifts. That's last. Okay. So number one is horizontal shifts. Number two is going to be horizontal stretches. Number three, vertical stretches. And number four, vertical shifts. So now we can finally graph our own parabola here. So first, this is the parent graph is going to be y is equal to x squared, right? We know that what that looks like. It's going to be a parabola like this. Okay. So what we do first is we're going to shift horizontally like this, like so. Gonna shift by 4 units to the left, right? Because we're adding 4, right? So now we're gonna have something like this, right? Actually, I have to plot these points. I'm not gonna plot directly. Okay, so all right, so parabolas kind of look like this. Now, what we're gonna do, you see, we have a negative, right? It's multiplying by -3, so we know to reflect it. Lastly, we're multiplying by -3, right? So what we're gonna do is we're gonna stretch it vertically. So we're gonna have something like this, stretched by a factor of 3, right? Okay, so each y value is just multiplied by 3, so it's kind of like that. All right, very skinny. Okay, so now let's look at one of these. Parent graph is going to be y is equal to square root of x, something like this. All right, so we can see that we're gonna have to do some of these first. Of course, we're gonna reflect it. We're gonna reflect it anyways. So let's just go ahead and do that. Okay. Now we have our horizontal shift of 2 units to the left here. Okay. And here is the tricky part. Here's the tricky part. Okay. See, now you're going to compress this horizontally, right, by 2. And by compressing horizontally, it's probably going to look something more like this, right? But no, it's not going to stay in the same position because you're already shifted 2 to the left. So by horizontally compressing it by a factor of 2, you're actually going to have to shift it back to 1 here. All right. And of course, after horizontally compressing it by a factor of 2, it's going to look like this a little bit more, right? All right. Not exactly to scale. It'd be more accurate if I use points, but we're running out of time. So you got to make it quick. All right. So remember that after you shift it and you compress it, sometimes you have to move it back. Right. Okay. So this is one of the main problems that I want to discuss today. All right. All right. Suppose that the point -2/3, well, not -2/3, it's going to be point P -2/3 is on the graph of y is equal to f of x. Find the corresponding point on the graph of y is equal to 2f of x minus 2 plus 1. We could do this a very, very tedious way. Let's just graph this. This would be extremely tedious because let's say we do this. Okay, let's say first we're going to move it to the right by 2 units. So we have this point. Then next we're going to do one of these. We're going to multiply, all right, by 2 because of the vertical stretch thing. And then finally we're going to add Again, one more, 1, 2, 3, 4, 5, 6, 7. All right, this is very tedious, right? So then you get 0, 7 as your point. Not the best solution, because you're gonna have to draw all of these lines, all of these graphs, all right, to get your answer. So I'm gonna introduce a new method. So let's say that this point is on your graph. That means that f of -2 is equal to 3, right? Is equal to 3. All right, f of -2 is equal to 3. So why not? Let's just the new y value is going to be equal to 2f of -2 plus 1, which is equal to 2 times 3 plus 1, which is equal to 7. Now that we got our y value here, we now need our x value. Since we set x minus 2 to -2, now we got to solve for it. X is going to be equal to 0. All right, so therefore we have our answer. X and y is going to be equal to 0, 7. So finally, before our time runs out, let's just do our last practice problem. All right. So we're just going to use the same point. Okay. Now you see here, if you tried that earlier method of graphing the point and trying to do all of that stuff to it, it's not going to work anymore. Look at all of these transformations. It's going to be super tedious and you're probably going to make mistakes. Right. So now we're going to use the new method. All right. My method. All right. For you. We're going to do -2 times f of -2 minus 3. It's going to equal to -2 times 3 minus 3 equal to -9. All right. Next, we set -1 half x plus 1 is equal to -2. -1 half of x is equal to -3. Okay, x is going to be equal to 6, right? So we get something like that. I feel like I made a mistake. Okay, let's see here. I don't think I made a mistake. It should be correct. All right, so then we get something like this. I'm gonna get 6, -9. Okay, so I think that's correct. You might want to double check that because I did this in a hurry. But that's basically the method to use. All right, that's basically the method to use. All right. So everybody, okay, William, you have a question? Yes.
So for that last practice problem, like, how do you how do you set the thing in the parentheses as -2?
All right, good question. Because, all right, you're taking the same x value, right? No matter, because you're taking the same x value, right? So let's just blur all of this out, okay, for a second. Because you're taking if you're taking the same x value, all right, let's just keep it as -2. Then right now you're just worrying about all the y changes, all right? Because no matter what you do in the parentheses, it doesn't matter to the y, right? Because all of this stuff in the parentheses are x changes, they're domain changes. So no matter what you do to it, it's not going to affect the y changes. That's why we set -1 half x plus 1 to -2 first, just to find the y value. Afterwards, we find the y value, all right? After we find the y value, okay, then we go back and set -1 half x plus 1 is equal to x to find changes in x, right? It might seem a little bit confusing, but after you use the method a little bit more, okay, it makes more sense. All right, so did I answer your question?
Oh wait, I have another one.
Yeah.
So does that mean that we could set it to like any number, like -1 or 3 or something like that?
No, because you have to use the x value of the previous point.
Like, what do you mean by the previous point?
This original point P.
Oh. Oh, okay, I get it now. Thanks.
All right. No problem. Okay. So that's going to be the last problem of today. All right. Hopefully everybody learned something today. All right. And I'll see you next week then. All right. Bye.
Bye.